Hello everyone, my name is Shambhavi. Hope you all are doing well. So, as in the previous video, we had discussed regarding the test of two variances. That what is this test of two variances, and basically what are the things we do and what we basically do not do. All of the things we have discussed out. Now let's quickly take out a very general example. I'm just not going to solve out anything or anything like that. It's a very general example that I'm going to take out. Okay. So I would just simply change out a color, then I would proceed on with the writing. Great. Okay. So here goes that suppose we sample randomly from two independent normal populations, normal populations. Fine. So suppose we sample randomly from two independent normal populations. Okay. Now, in that case, what we are having, the things that need to be put on here, I need to be remember out as well. Okay, dot. Fine. Now here we have let sigma 1 square and okay, and here we have sigma 2 square. So sigma 1 square and sigma 2 squares, these let be the population variances, and s1 square comma okay be the population variances and okay, this is s1. One second, let me write down 1 very clearly. 1. Okay, s1 square multiplied by not multiply, here will go the and. Let me just get down here. So suppose we sample randomly from two independent normal populations. Let sigma 1 square and sigma 2 square be the population variances, and s1 and s2 squares be the sample variance fine. So one second, right here. So let these are sigma 1 square, sigma 2 square be the population variances, and s1 square and s2 squares be the sample variance, right? So in that case, now basically what is gonna happen? Full stop. Let the sample sizes be the population variances. Okay, let the sample sizes that I have already done that. Let the sample sizes be the okay, not population, it's that another one. Let be the n1 and n2. So n1 and n2 are basically the sample sizes which we have here. Okay, n1 and n2. Fine. Next, since we are interested, next is basically right here. Now, let's say we are interested in comparing the two sample variables we use for the F ratio. So in that particular case, yes, of course, we could use out this particular type of like you could use this particular type of question or answer this out in this particular way and rest all of the things, right? Fine. So basically, as we just wanted to find out and we're interested in comparing the two sample variances. So in that case, we're going to use out the F ratio that's formula. Okay, let me just come down and show you that F ratio 1. So here it goes that F is equal to, then okay, now we are having S1 and S2. It goes S1 upon S2 whole square right here. Okay, just like this. After that we have this, then we have the second one as well. Okay, so into that particular case I'll be mentioning out here S2 Okay, S2 in the bracket we have S2 squared divided by and that is completely sigma 2. Right, sigma, okay, 1 second. And here it's sigma down wala na, right? So here sigma 2, fine. So if this is the particular formula that we have out here, S1 upon, okay, that's S1 upon sigma 1 and S2 upon sigma 2. So let me now just clear out the complete formula and write that out again. So here we go on to the draw, and I will just run all of the things whatever we have written till now. Into that case, this draw comes here, and I will just put on the different things. Let's put on the formula first of all, fine. So F is equal to, I have this one particular block, okay, and onto that particular block we have S1 squared upon, okay, 1 second, S1 squared, and here we have V1 squared upon, we have S2 squared, okay, we have S2 squared, and then down the line, down this particular one, we have sigma 2 whole squared. Right, so yes, this is how we just put on the things, we just put on the relevant formula. So after this, basically, what is this F having? So F has the distribution, here goes the, F has the distribution, that is capital F approximately equal to, this is capital F, and into the bracket you have n1 minus 1, comma n2 minus 1, okay, where now into this case n1 minus 1 are the degrees, are the, okay, let me remove that out, n minus 1 are the degrees of freedom, okay, degrees of freedom for the, numerator, and for the numerator, and n2 minus 1 numerator, and n2 minus 1 are the degrees, of freedom for, the denominator, denominator, fine, are the basic degrees of freedom for the denominator, right? So yeah, hope I am very much clear with all of those things whichever I have mentioned out. So let me give you again an idea. So we have taken on an example that suppose we sample randomly from two independent normal populations, right? So let sigma 1 square and sigma 2 squares be the population variances, and S1 square and S2 squares be the sample variance. Let the sample sizes be N1 and N2. So F is equal to S1 square upon V1 square upon S2 square upon sigma 2 squared. Fine. So it has a distribution F belongs to F, that is in the afterwards, which is on the right hand side F. Inside that we have N1 minus 1, comma N2 minus 1 ke pure, like they have. Then we have n1 minus 1 are degrees of freedom for the numerator, and n2 minus 1 are degrees of freedom for the denominator. Right, so hope I am very much clear with whatever I just referred regarding the F distribution. So this is all for this video. Till then, thank you and take care.